So here's part D of number 3 from the 2012 AB and BC exam. And in part D they say for the open interval -4 to 3 find all x values for which the graph of g, not the graph of f, but the graph of g has a point of inflection. Explain your reasoning. Now points of inflection happen at places where a function has changes in concavity. And concavity is determined by the second derivative. When the second derivative is positive, our function's concave up. When the second derivative is negative, our function's concave down. So we would need to figure out where the second derivative of g changes signs, and before we can determine that, we're going to need the second derivative of g. Now in part B of this video, we took the first derivative of g using the fundamental theorem of calculus. If we're looking for the derivative of this function right here, just take that upper limit, that x, put it in place of the t. That part of the fundamental theorem of calculus essentially says that derivatives of definite integrals are going to leave you with the integrand. You might have to use the chain rule from time to time. That didn't impact us here because we did not have an inner function of x there. We just had a regular old x. So here's g prime of x. If we want g double prime of x, g double prime of x is going to be, well, the derivative of f is f prime. So g double prime corresponds to f prime. Now, if we want to determine what the sign of g double prime, the second derivative of g, is for all values in between -4 and 3, in other words, build a sign chart for g double prime, we're going to have to figure out when g double prime is equal to 0 and figure out when that second derivative is undefined. So the second derivative is equal to 0 at any places where f prime is 0. Now here's a graph of f. Slopes of the tangent lines on this graph are going to determine values of f prime and, in effect, g double prime. The slope of the tangent line is definitely 0 at this spot on the semicircle, and that happens at the x value of 0 since the circle is centered at 0. And there aren't any other places where the slope of the tangent line to f is 0. Now there are two places where the slope of the tangent line to f is undefined. So when is g double prime undefined? Because the sign of g double prime could change as we first cross an x value where our derivative is undefined. And our derivative is undefined, our second derivative is undefined, when the first derivative of f is undefined, or when f is not differentiable. F is not differentiable at this cusp, which occurs at an x value of -2. And it's also not differentiable at this cusp, which occurs at an x value of 1. So these are the places where the sign of g double prime could potentially change. So I'm just going to put those as possible split points in my sign chart for the second derivative of g. So I want to make sure I get them in order. So -2, 0, and 1. What's the sign of g double prime between -4 and -2? Well, since g double prime equals f prime, between -4 and -2, what's the slope of the tangent line to f? What's the derivative of f's sign? Well, it's a positive slope there. In between -2 and 1, we have negative slopes for f. So negative values for f prime, which equals g double prime, negative values for g double prime. In between 0 and 1, we see actually there are more negative slopes here. Right? I should have grouped all of those together with that first circle. That wasn't a place where I was crossing an x value that g double prime could potentially change signs. So we have negative slopes from this x value clear to this x value. And then from the x value of 0 to the x value of 1, we're looking at positive slopes on that portion of f. So positive value for f prime, positive value for g double prime. And then we're looking at a few more negative slopes to wrap things up between positive 1 and 3. So this tells us that g double prime is concave up between -4 and -2, concave down between these x's, concave up between these x's, and then concave down between those x's. So find all values of x for which g has a point of inflection. We do have a change in concavity at this x value, and this x value. So the x values that represent inflection points are -2, 0, and 1. Explain your reasoning. The sign of g double prime changes as we cross those x values.